Okay, 7.1. So chapter 7 is kind of our switch from descriptive statistics into... So 7.1 is going to be our switch from descriptive statistics into inferential statistics. So we're going to start to talk about how to get from just a data set with a bunch of things about it to actually making conclusions about that data set. So 7.1, we do need to get a couple of vocabulary words in there. Parameters is going to be a description of a characteristic of a population, and a statistic is a number that describes a characteristic about a sample. Okay, so how I like to remember that is remember if you have a population and there's something that you would like to know about that population, what you're trying to know about it is the parameter. Notice the P's, population, goes with parameter. And if you have a sample and you're trying to estimate something about that sample, then that is what we call a statistic. Okay, and again, S and S. So something like if I wanted to estimate the mean number of sports that Livonia High School students play, and I randomly select a sample of 10 students and figure out how many sports they play. So in this, my population is Livonia High School students. My parameter is the average number of sports that are played. My sample is the 10 students, and then the statistic is the average for those 10 students. And if we randomly select, then we're able to apply that statistic to the population. Okay, so if we randomly select, we still must be random. If we randomly select our 10 students, then we are able to apply that information to the population. And very rarely do we actually want to know things about a sample. Usually we want to know things about a population. So we use a sample and its statistic to estimate the parameter of a population. Okay, so what's going to be different about this unit is this thing called a sampling distribution. So a sampling distribution is when you take those 10 students that I just talked about and you calculate the average number of sports that they play. Then you plot that point. So you plot that average. And then we're going to throw them back into the mix and we are going to randomly select again. And then we're going to calculate that average. And then we are going to plot that point and we are going to throw that back in. So this graph over here to the side is what we would call a sampling distribution. So before, each dot would mean 1 point. That no longer means that anymore. It is the statistic of a sample of a certain number. In this case, it's 100. Okay, so each point right here. So for instance, this first question says there's a point on the graph at 2. That does not represent a 2. That represents, what are we doing here? Finding the median. The median equaled 2 for one of the 100 samples. Okay, so there's 100 dots right here, and one of those samples had a median of 2. And I didn't explain what was happening here, but basically you've got a deck of cards. We're just going to use the numbers 1 through 10. We're going to select 5 of those cards and we're going to calculate the median. So you can think about how that could occur. How could we get a median of 2 if you want to? Describe the distribution. So whenever you see that described, make sure you talk about S, O, C, and S, and then at some point put it into context. So we are symmetrical, no outliers. Center is going to be right there around 6, and then your spread is going to be from 2 to 10. You could also use the interquartile range if you wanted to. And again, put that in context. Would it be surprising to get a sample median of 4 or smaller from this deck? So all you would need to do is calculate how many dots are there 4 or smaller. Now again, the big point about a sampling distribution though is that each point does not represent 1. It represents the median of a group of 5. So you would count up all of these dots right here. Count them all up. I don't know how many are actually there. Count them up and then determine that out of 100. So figure out how many are there out of 100. Figure out what that probability is. Now, whatever that is, that should be, it is greater than 0.05. And remember, 0.05 is our unusual. So as long as it's greater than 0.05, then we would not be surprised. Okay, so our probability here, after you count them up, that's going to be greater than 0.05. So no, we are not surprised. And then the last question here, if the median is 4, don't worry about that one right now. We'll come back to that in a little bit. I want to make this video pretty short. So basically what you need to take away from this video is that no longer do these dots represent one card. They are the median of 5 cards. And that's where you get a sampling distribution from. It is something about the statistic of a sample, and then we are going to plot it. Now, we want these sampling distributions to be unbiased, okay? So we're going to call them unbiased estimators. Now, with an unbiased estimator, you're looking for 2 things. You're looking at its center, and you're looking at its spread, which, by the way, center doesn't always mean mean. It can be median, okay? So if it's a skewed distribution, make sure you look at the median. We talked about this before. So if your median matches the parameter, if your statistic matches the parameter, then you have an unbiased estimator. A statistic estimates a parameter, that would mean that you have an unbiased estimator. You also want to look at your spread. You want low variability. Okay, so what I did was I did put this into like a little flow chart here. So if you're asking if something is an unbiased estimator, the first thing you're going to consider is the center. So does the center match the parameter? Then yes, it could be, I guess you probably don't need to worry about this side over here. So unbiased estimate, does the center match the parameter? If yes, then it is an unbiased estimator. If no, then it's not an unbiased estimator. Okay, so center must match. That's number 1 most important. So remember, you're going to look at the median or the mean, and then you're going to look at variability. Less variability is a better estimator. More variability is a worse estimator. So here's an example here. You can pause this if you want to, but we're going to just look through and see which one of these would be the best estimator. So let's look and see, first off, which ones do the center match. So the center of your distribution has to be the center. I would say probably this one does not work because your center should be probably a little bit more this direction, I would assume. The rest of them, the centers pretty much line up, so they would be okay. So then you're going to look for the one that has the least amount of variability. So in this case, it would be the partition one. So even though it's skewed, that doesn't matter. You're just looking for, does the center match, and then the smallest amount of variability. And I think that's what that second question there asked was, why would this be used? Well, because the center matches and there's the least amount of variability. So the thing I want to review the most is to go up and talk about the sampling distribution. So right here, remember, each dot does not represent one card anymore. It is the statistic of a sample. So it is the median or the mean or the interquartile range, whatever that is, of a sample. So it is a statistic. And then I'll leave you with this slide right here to figure out if you have an unbiased estimator. Remember, center matters first. And then after you look at that, make sure you have less variability to get your best unbiased estimator.